Okay. So I think 8 of you, yeah. Okay, so today, as usual, as we plan, we go through the questions first. If you have any questions, if you don't have, we're going to start with a new topic, the last one, before your semester exam. Okay, any questions? Anyone have any questions from this superposition you tried during weekends?
Can Sir explain again about the mistake last
Oh, the
week?
mistake. Yeah, the mistake is the overlapping. I wrongly stated. I stated at the beginning correct that, but towards the end is a mistake. This is the slide. I think okay. I can see the slide. Okay, the one I made a mistake is here. Okay, this one. This is the mistake. I said third order of red overlap with the second order of violet. This is wrong. See this diagram should be with the second order of red, right? Second order of red must overlap with the third order of violet. That's the mistake. So this should be second. It's not third, and violet should be third. Okay. So therefore, the calculation going to be different. This calculation, where's the calculation for the rate? This calculation. This calculation is going to be wrong. It should not be 3. It should be second. Second of rate overlap with the third of violet. Therefore, the answer will be changed to what? 3/2. No, correct. So this is a mistake. Okay. Okay.
Thank you, sir.
Okay, good. Thanks. Okay. Any other? Yeah, go back to the question. Okay. So, any questions from this superposition? I think the time is too short. I think I should give you 2 days for you to do. Maybe I haven't tried yet. Okay, if you don't have questions, maybe I'll ask back tomorrow. If you have any, we go back to the new topic. So no questions. We can go to the new topic. Let me check if everyone is here. Okay, good. So many, all of you. Okay, so let's start new topic. We don't have any questions. Okay. So then the last topic for your semester exam is your electric field. Of course, AS consists of how many topics? You have 13 topics. 13 topics, but we only go up to 10 topics for your semester exam. Okay, the last topic you're going to do is today is electric field. Okay, so electric field is the topic we're going to do. Okay, before we talk about electric field, I think I already informed you there are how many types of field in this world? 3 types of field. What is that? Gravitational field, electric field, magnetic field. Okay. So gravitational field and magnetic field will be doing in A2. Electric field will partially be doing in AS. 50% in AS, another 50% in A2. Electric field. Okay, what is the use of electric field? Anyone? Where do we use electric field?
Use a current.
Yeah?
Produce a current.
Produce what? Current.
Current.
Okay, produce current, you need a voltage. Okay, some sort of like we need electric field. Okay. Any other uses of electric field? Which device uses electric field?
Oh,
Any device like uses electric field technique?
CRO.
Very good. That's the main one. Cathode ray oscilloscope. CRO inside uses electric field to deviate the electrons so that we can analyze the alternate signals, heartbeats and any alternate signals, sound from beds and everything they want to analyze. We have to use CRO. CRO uses electric field. Any other electric field applications? Capacitor, you heard of capacitor?
Oh yeah. Like
A capacitor, electronic device which stores charge, works based on electric field, storing charges. Okay, and of course, electrostatic force, electric field is used in a photocopy machine also. The photocopy, the what do you call the words to be stick on the paper is based on electrostatic. So yeah, these are the electric field. And the fourth, those who are taking chemistry. Anyone taking chemistry? Yeah,
yeah, I'm taking chemistry.
all of you taking chemistry. Okay. So chemistry, heard of mass spectrometer?
Yes. Oh yeah.
Mass spectrometer. What is the use of mass spectrometer?
Determine average mass isotope.
Isotopes. Yeah. If you have a chemical, we want to see how many types of isotope contains in that chemical. We vaporize it and we make it vaporize it, and we use the electric field to accelerate it to gain kinetic energy, and later magnetic field involved to find what type of isotopes contains in that substance. So mass spectrometer uses electric field and also magnetic field. Okay, so what is electric field? So what is electric field? So yeah, so this is not a, so I skip this, it's not a magic. So what is electric field? Electric field exert force on each, they are distance apart and the charge is apart. So meaning they can influence each other without touching. So the idea of electric field is brought up to represent the invisible contact between the positive and negative charges. This is the, what is electric field? Is a region of space where a charge experience force. Okay, a charge experience force. You don't need to tell stationary. Okay, I think no need to tell stationary. Don't need to tell stationary. Just say a charge particle experience force. Because not only stationary will experience electric force, a moving charge also can experience electric force in electric field. So what is electric field? A region of space where charge experience force. Okay. What is gravitational field?
A region of space where object containing mass experience a force.
Very good. A region where mass object experience force. Okay, I don't expect this. Let's see. What is magnetic field? Anyone?
A region of space where magnetic objects experiences a force.
Okay, good. Magnetic object experience force or moving charge particle experience force. Moving charge particle experience force. Okay, good. That's A2. So now for time being, what is electric field? A region where charge particle experience force. Of course, the force can be attractive, can be repulsive, depend on the nature of the charge. You know that. Yeah. Okay. Electric field lines. Electric field lines. What is electric field lines? It's invisible. The electric field is in fact is invisible. You can't see the field, but you can't see the pattern, but the charge particle can feel the effect. The electric field lines is a convenient way of visualizing the electric field. So we want to produce a field line so that we can visualize it. Okay, we can imagine it how the electric field line looks like. So the electric field line is start at a positive charge. The electric field sign is beginning from the positive charge and ends at negative charge. Okay, this is the rule we fixed. Okay, electric field start from positive charge, reach the negative charge. Yeah, if the electric field line is more dense, the field we assume is stronger. Okay, the separation of the field line is quite close, then we say it's stronger. The electric field lines cannot cross. Yeah, the electric field lines cannot cross each other. Okay. Another important one, let me show you here. if you have a shape like this, non-uniform shape, and it's positively charged, okay, the electric field line always come out from the surface because of positive charge, so it's going to be go outward from the positive charge. The field line always perpendicular to the surface. When the field here, the field line have to be drawn perpendicular to the surface, going out. The field here, perpendicular to the surface. So the rule is, when the field line go out from the body, you have to be perpendicular to the surface. Please add that as one point. The field line must be perpendicular. It must be perpendicular to the surface. But when the field line comes out, let's say the second and the third field line, when it comes out, towards the end, they can't cross. They'll move like this. They might move such a way, the bend later, such a way that they won't cross. No crossing. No crossing of field lines. Not only in electric field, also in magnetic field and gravitation field works the same way. Field lines never cross. Okay. So I believe start at positive, ends at negative. More dense, yeah, the field line, if it's quite close by, very close, then we say the field is stronger. And when the field line is getting further, we say the field is weaker. Okay. So the last point, something new for you, perpendicular. And field line cannot cross. Okay. Any questions from this slide? Make sense, Okay. So I believe you know this. Positive charge, the field line going outward, the field line going away. Of course, the field here, because the separation is nearer, so the field is stronger. Okay. This separation is greater, so the field is said to be weaker. It's weaker. Okay, same thing. Positive. If a negative charge is going inward, but it's -2, so the field should get stronger. So how do you show the field is stronger? You draw more lines. More lines. It should be more denser compared to the positive Q. Positive Q is 1 magnitude. -2Q is 2 magnitude. So the field should get stronger. So in exam, they'll ask you to sketch the pattern. Okay. They'll tell you maybe positive Q, this is the pattern. If positive 2Q, how's the pattern? So you need to increase more lines. It should be more denser. Okay, if the charge is twice the magnitude of the charge of A, the opposite in sign, so they are twice as many field lines and they point towards the charge rather than away from it. Okay. Okay, sometimes you will have two charges. These are the patterns. Okay, you leave from positive, you reach negative. Okay. Okay, good. I'd like to ask you one question. You see here this pattern. You see this pattern. Okay, let's say electron was placed here. Electron was placed here. Hope you can see the electron is placed there. Which direction the electron will experience a force if an electron is placed at this location? Okay, you need to draw a force direction arrow. Is it to the, okay, let me check. Let me use a different point. Hold on. Okay, is it the force is going to be this way, one, or the force is up, second one, or the force is going to be like this, third one, or the fourth one? Which way? An electron is placed here, the location. Is positive charge, negative charge. This is the field line looks like. Electron is placed somewhere on the line. So electron will experience a force which direction? Or let me add another one. Or is going to be like, yeah, 1, 2, 3, 4. Anyone?
1.
Should be 1. Should be 1. 3, 4. Of course, the other 3 is not. It have to be directed to the positive charge. The direction of the force, if I put electron here, let me check. Okay, let me put electron here. Okay, see the electron here in the second place here. here where the force you direct. Is it going to the force experienced by the electron? Is it this way, 1, or like this tangent, 2? 1 or 2 is the force. Anyone? Is it 1 directing towards the positive charge, the electron going to move, or the force going to be parallel to the field line? Parallel to the field line. So the answer is 2. This is the direction of the force. Okay. Don't ever draw the electron going to attracted to the positive. Of course, it's going to attract it to the positive, but the force acted on the charged particle is parallel to the field line. If the field line is like that, it's going to be, the force is going to be parallel. So the electron have to move up, then have to follow the field line, and not direct to positive charge. Okay. So yeah, the same thing. These are the another field lines, and the field pattern shows is a uniform field or non-uniform field. This is a non-uniform field. What is meant by non-uniform field? The field separation, the line separated at a different length. Closer, the field is stronger. This is stronger field. This is weaker field. So this is a non-uniform field. Non-uniform field. Okay. Non-uniform field we'll discuss a lot in A2. Okay. In AS, we talk more about uniform field. Okay. So these all are patterns. Okay. So many patterns. Positive, negatives. From positive, negative, the field going to looks like. Positive, negative is going to field going to go down. Okay. So we have many fields. I skip this because this is not our area of concern now. We are more to parallel, what you call uniform field for AS. Okay. What is a uniform field? What produces uniform field? A parallel plate. Parallel plate produces a uniform field. Okay, so this is a parallel plate. So we have a positive plate and a negative plate at the side, parallel plate. If you connect it with the positive voltage and a negative voltage here, if you apply a voltage across this by using maybe a battery, connect a battery, let's say if a 10 volt or 20 volt, this is going to be positive 10 volt, this will be a 0 volt. So it creates electric field. Okay, the electric field created in a parallel plate is a uniform field. So how do we draw the pattern for a uniform field? Uniform field means the field separation, the line separation must be constant. If this is separated by 2 centimeter, throughout the separation of the field line is 2 centimeter. Every line must be separated by 2 centimeter. So then it's called uniform field. Okay, it's a uniform field. So uniform field, the lines must be parallel, must be equidistant. Okay. So a parallel plate consists of 2 conducting plates which equal and opposite charges. And what is the difference between these 2 types of field? This is, as I said, this is a uniform field, and this is your non-uniform field. Okay. Okay. There is one year they asked to draw the uniform pattern. Okay, for a parallel plate. A student draw a parallel plate. A student draw a field line like this. It was parallel. Okay, no doubt about that. Positive and negative, yeah. But it was parallel. But towards the end, the line was okay. So is it a uniform pattern? You won't be given a mark. It have to be parallel, at the same time have to be equidistant. Make sure the distance separated is the same. Okay. Okay. So what is electric field? It's a region where a charged particle experiences force. Okay, now we have another field strength called electric field strength. Okay. So electric field strength is defined as, I think this is more important than definition. Electric field strength. What is electric field strength? Electric field strength is a point defined as the force per unit charge on a test charge placed at that point. Okay, there is an important keyword missing here, which carries 1 mark. Force per unit positive test charge. Okay, class, please include that word, positive test charge. The word positive carries 1 mark. Okay. So electric field strength, a point defined as force per unit positive charge on a test charge placed at that point. Okay. So if the force experienced by the positive test charge is positive Q, the electric field strength symbol is E. Okay, this is electric field strength. This is electric field strength. Symbol is E. Is equals to force per unit positive test charge, positive charge. We say positive charge. It's called field strength. Okay. Same thing, gravity. Gravitation field strength. Gravity is force per unit mass. I don't know whether you realize or not. Okay. F equals to mg. Your G is your gravitational field strength. It's actually defined as what? Force per unit mass. Force per unit mass. Our Earth field strength is said to be 9.81. Our gravity is 9.81. Means what? We experience 9.81 Newton of force for every kg of your mass. That's your field strength. How many force you get per unit mass is your gravitational field strength. Same thing go for electric field. Electric field, how strong is the electric field? The electric field is the amount of force experienced by the charged particle divided by for every unit of charge it carries. That's the electric field strength. If the electric field strength is 20 Newton per coulomb, that's a unit for electric field strength, Newton per coulomb. So we said the field strength is every charge it carries 20 Newton of force has been exerted. If it's 50 Newton per coulomb, so we say the field is stronger. Yeah, same thing. So field always electric field strength. The field strength is defined as always force divided by something. It's called the field strength. Gravitational field strength, force per unit mass. Electric field strength, force per unit charge. And magnetic field strength later also something to do with force per unit something. The magnetic is a little complex. We will get to know that. Yeah. So what is electric field strength? Force per unit positive charge. Greater the force it experiences, the particle, we say the field is stronger. Okay. Okay. So the unit is, of course, is Newton per coulomb. The unit is Newton per coulomb. Okay, this is the first formula you learn. Okay. So uniform field. The electric field strength is uniform, always same in every point. The field strength is same. So if you have an electron placed here, or you place an electron here, or place an electron here, all of them going to get the same force. Because of what? The field strength is the same. Okay. The electron will experience a force in which direction? To the left, parallel to the field line. All of them going to shift to the left with the same force. Okay, as long as they have the same charge. Okay. But let's see here placed with a proton. If you place with a proton, the proton and electron, do they will experience the same force? Proton will move to the left, to the right, sorry. Do they will experience the same force? No. The field is same, but the force experienced by the electron and proton will have the same force or different force. E equals to F over Q. So the amount of force they're going to experience depends on the field strength multiplied by the charge the particle possess. So electron and proton have the same charge, right? They have the same charge. Therefore, they will experience the same force. The proton and electron will have the same force. Okay. You heard of alpha particle, right?
Yeah.
Alpha particle. So alpha particle will, what is the charge possessed by alpha particle? Anyone? Proton is +1, electron is -1, alpha is
4.
positive. Alpha is actually made of what type of particle? Helium, right?
Yeah.
It's a helium nucleus. So what is the number above? 4. It's a 4 nuclear number and 2 proton number. So nuclear number or proton number determines the charge of the particle. Proton number is 2 proton number. So alpha is +2 charge. +2 charge. So alpha will have, okay, I need to tell you here, electron say to be -1. Is that means, what is the unit for charge? What is the unit for charge? What is the unit for charge? Coulomb, right?
Coulomb, yeah.
Okay, electron, last time we said -1 is charge. Is that means -1 column?
No.
No, it said to be -1e. We call it 1e. We call it 1e. The e carries a value. The value it carries is 1.6 times 10 to the power of -19 column. Okay. This is a constant. It will be in the front page of your question paper. We call elementary charge. So electron is -1 means it's not -1 column. It's -1e. E carries some value 1.6 times 10 to the power of -19. So charge of electron is -1.6 times 10 to the power of -19 coulomb. So what is the charge of alpha will be? Positive 2e multiplied by e. The symbol of charge is e. So it's going to be positive 2 times 1.6 times 10 to the power of -19 coulomb. And that is the charge of alpha. So the force experienced by alpha, how many times greater than the electron? How many times will be greater than the electron? Because it's 2e, what? Electron is just 1e, alpha is 2e. So force is what? Force is E times Q. Q of alpha is 2 times greater than the electron. So the force of alpha will be 2 times greater than the electron. But in a what do you call, in a negative direction. Okay. So what I'm trying to tell here is a charge possesses a particle possesses a big amount of charge, means the amount of force you're going to experience is greater. Okay, in a field. Okay, so now here it is. Okay, now we have another electric field formula. There are two formula for electric field. Electric field produces in a parallel plate. You can strengthen the field, you can weaken the field. The field strength of the parallel plate is dependent on two factors: the voltage you apply across the plate and the plate separation. Okay, this determines the electric field. So V is the potential difference between the plate and D is the plate separation. Okay, so you want to get a stronger plate, a stronger electric field strength in between the plate. What do? We just connect with the battery with a greater voltage. You must keep a greater voltage. Or what do? If you can't afford to keep a greater voltage, let's say you don't have battery or something, you can reduce the separation, decrease the separation. The plate, just bring it closer. Just bring the plate closer. Okay, have a smaller D, then the electrical strength will get stronger. Okay, so greater the V, smaller the D will lead to greater electrical strength. Okay, when the field is very strong, what will happen? The air particle can start to ionize, produce spark. Spark will happen if the field is very strong. Okay, field is very strong. Like you know, right? The Earth and the what? The Earth and the what do you call? The cloud. When the cloud is so charged, highly charged, it will be charged. Let's say negatively charged. When it gets closer to the Earth will be induced with positively charged. So it turns. So the cloud and what do you call? The Earth produces electric field in between the region. Okay, so the positive and negative, it create electric field. There will be electric field. Okay, so what happened? The air particle in between, the air particle in between can be charged. If the field is get very strong. Okay, if the field get very strong, definitely the field going to be much stronger because the cloud is rubbing with the air, so you gain more charge. So therefore the E will be get stronger. So the air particle will start to ionize. Okay, what is meant by ionization? What is meant by the ionization? The air particle consists of nucleus, which is positively charged, but the electron is negatively charged. You know that. But in this, if the air particle is, of course, we know it's neutral. But when it's in the electric field, when you apply electric field, up is positive, down is negative. Of course, the positive nucleus want to go down, but the electron it like to go up because they attracted in a different plate. Okay, so what happened? If the electric field is so strong, then the electron will strip off from the atom, and what happened? the electron become negatively charged, and the remaining atom going to become positively charged. They become conducting. This process called ionization happen. Ionization only can happen when the electric field is quite strong. Okay, when the electric field is quite strong and capable to remove the electron, because when the field gets stronger, E equals to what? F over Q what? So F is what? QE. When the electric field strength gets stronger, then the force exerting on the electron going to be very strong. So electron capable to come out from the atom produces ionization. So ionization causes the electron and proton, what you call nucleus produced. Then electron tend to move up, and the nucleus tend to move up to the cloud, and the electron would like to move to the earth down. The collision of these two particles produces like a lightning happens. Lightning happens. Okay, so electric field. Okay, so electric field. The cloud and the earth is acting like a parallel plate also. The separation is the D, and if the cloud has more charge, the potential difference between the clouds and the earth becomes stronger. The field gets stronger. Okay, when the cloud get closer and closer to the earth, the field get even stronger, and ionization can happen. Okay, that's why ionization, the lightning happens now, because of the atom become conducting. Okay, the air molecule become conducting by removing the electron. Okay, any questions from here, this slide? Okay, so you learned two formulas so far. Electric field strength is what? Force per unit positive charge, or electric field strength is V over D. But in exam, if they ask question, define electric field strength, if you write potential difference divided by the plate separation, you get 0 mark. You won't get mark for the defining V over D. You have to define electric field strength as force per unit positive charge. Don't define by using V over D. Okay, every quantity can have lots of formulas, but only one formula defining it. Okay. Okay, now the electric field strength got another unit. It's called volt per meter. Because V is volt, D is meter, so it's become volt per meter. So this is another unit. Okay, so you can have Newton per coulomb, or you can have volt per meter. Okay, both unit for electric field strength. Okay, but this unit, you break into the SI base unit, you'll get the same SI base unit. You'll get the same SI base unit. Okay, any questions? Okay. Okay, so now we go for an example. So you see there is a parallel plate, was horizontal. The field line is from positive to negative. 28 volt was applied, and the plate is separated 0.14. Okay, the first question, what is the electric field strength produced by the electric field? So what is the formula will be used? 28 divided by 0.14. So what formula to be used? Of course, E equals to V over D. 28 divided by 0.14 is the strength, 200 volt per meter. Then what is the force on 2 nanocoulomb of charged particle placed between the plate? Okay, let's say a charged particle of 2 nanocoulomb is placed here. How much is the force you're going to experience? So what formula to be used? Of course, F is QE, Q times the field strength. So 2 times 10 power negative 9 times 200 will give you the force experienced by the charged particle. 4 times 10 power negative 7 Newton in this case. 2 nanocoulomb is, of course, we know is 2 times 10 power negative 9. Okay. Okay, now which direction the force will experience? If is positive 2 nanocoulomb is placed in this plate, positive 2 nanocoulomb will move directly down, go towards the negative plate. The force should be directed parallel to the field line, must be parallel to the field line. Okay, in exam they will ask to draw the force, you must draw parallel to the field line. Okay. Okay, I think the earlier one is quite straightforward. Okay, now let's go beyond that. You have a parallel plate of 500 volt is given up and 0 volt at the bottom, separated by 5 cm. Okay, two closely spaced metal plate connected 500 volt. Draw solid line to represent the electric field between the plates. Add arrows to indicate the direction of the field line. Okay. So yeah. So what do you have to do? You have to draw a straight line. Okay. Difficult for my pen to draw here. So you have to draw by using a ruler. You draw a straight line. Straight line down. Okay. When you draw, make sure it's equidistant. If this is x, means this also must be x. And the direction, positive to negative, positive to negative. Okay, so yeah, this is how the drawing should be. You can draw up to here. Sometimes the edge, the field line will be slightly curved. Okay, slightly curved, only at the edge will be slightly curved. Okay, because when the field line comes up from the edge, you have to be perpendicular to the surface. You have to be perpendicular to the surface. So you have to be curved and come down. Okay. Okay, but if you never draw the curved one, you won't lose mark. The important is the parallel one in between. Okay. Okay, so continue with the earlier one. Plate separation is 500 volt. Sorry, the voltage given is 500 volt and separated by 5 cm. We're using this data. Okay, if an electron is placed between the plate, find the force on the electron. So what is the force on the electron? What formula do you use? The charge of electron is this is called elementary charge. No need to remember. They will give you an exam in the front page of the question paper. All constants are there. Look for elementary charge. 1.6 times 10 power negative 19 coulomb. Okay, so what is the force? Of course, first you find the electric field is V over D, and later you have to use E equals to F over Q to find the force. So the F is QV over D. So the charge times voltage divided by the plate separation will give you the force. It's 1.6 times 10 power negative 19, 15. The force is very small. Although the force is small, the acceleration is going to be small or huge. Although the force is small, acting on electron, the acceleration is going to be huge or small? Anyone?
Well, relatively huge.
Relatively will be huge. Why?
The mass, not the mass, the charge is small. Wait, the charge is small, but the force is a lot bigger than the charge.
You see, the force is very small. The force is very small, but the acceleration is going to be relatively very huge. Because of what? Because the mass of electron is very small. Very small. Mass of electron is very small. The mass of electron is 9.1 times 10 power negative 31 kg, and it's very small. The mass of electron, mass of proton, all given in the front page, all the constants. So it's very small, therefore the acceleration is going to be huge. That means you have a parallel plate. Although the voltage you supply in the parallel plate is very small, but the electron is going to cross the plate with a huge acceleration, very huge acceleration. So the time of crossing the plate is going to be very, very small. Okay, you can't see it's crossing. It's very fast. You're going to cross because the acceleration is huge. Why acceleration is huge? Because the mass is too small. Okay. Okay, so we're going to strengthen your information, knowledge about these two. Okay, you only learn two formulas. What is that? E equals to F over Q and V over D. Okay. So based on this, let's try one. That is a again. A proton is placed in a uniform electric field where the plate separation is 30 mm and 5 volt respectively. Okay. So the question is, find the force on the proton. So the charge of proton and electron is the same, still 1.6 times 10 upon 19. So what is the force? What formula do you use? So you have to use these two formula, right? You want to find force is equals to bring the Q the other side is QV over D. Q, you know, 1.6 times 10 upon 19. V is the 5 volt and D is separation 30 mm change to meter. So you should get 2.7 times 10 power of negative 70. Correct? So because you want to find force, the formula must come to your mind is QE. Then E is V over D, and you substitute the answer. So of course, his charge is 1.6 times 10 power of negative 19. And V is what? V is 5 volt. And D, D is the trap, the TMM change to meter, 10 power of negative 3. Okay, good. So you get this answer. Okay. Okay, so we're going to continue with this question. So now you got your force. Okay. So, sorry, before that, okay. Once you got the force, let's say this is what this proton. Let me add more questions. The proton is, let's say, placed closer to the positive plate. Let me change color. Okay. So let's say the positive charge is placed, the proton is placed close to the positive plate. Yeah, the proton is here, positive plate, proton. Okay. The force experience is this much because now you know the force. Now you know the force. Once you know the force, can you find acceleration? You can find the acceleration, right? What information they must tell you? To find the acceleration, you know the force. You want to find acceleration. The information they must tell you is the mass of the proton. Okay. So if they give mass of the proton, you can find acceleration. Once you know acceleration is a member of kinematic, you know. So acceleration, if acceleration is given, now they're going to ask all the questions about kinematic. What is kinematic? The SUVET, the U, V, A, U, V, what? U, V, T, and S. Okay. Okay. So now you know the acceleration. Initial velocity, let's say, is 0. They will ask, what is the time taken for this proton to cross the plate? What is the time taken for the proton to cross the plate? They will ask the time. Okay, how do you find the time? Again, you recall back your kinematic, your SUVET formula. Need to recall back. Okay, so let's say I ask you the time. What is the time taken for this proton to cross the plate? Okay, after you find the acceleration, do you know 3 informations? What is the time taken for the electron to cross the plate, the proton to cross the plate? Okay, let's say it was dropped, initial velocity 0. So U is 0. Acceleration you can find by using the mass of the proton it provided. The mass acceleration we can find. Then we want the time. Okay, we want the time. So what another information you know? What is another information you know? The distance. You know the distance. The plate separation is 30 mm. So 30 mm is going to be your distance, your displacement, which is 30 times 10 power of negative 3. So it's going to be kinematic. Okay. Once you know acceleration, initial velocity most probably going to be 0. So they will ask what is the time taken to cross the plate, and they can ask what is the final velocity. What is the final velocity when reach the plate? Okay. So my what I'm trying to say is the kinematic, the SUVET going to be involved here again. Okay. So first you need to get the force from electric field. You need to get the force from electric field. Then F equals to ma can let you to find the acceleration. Once you know acceleration, they can use the SUVET already. They can ask the time. They can ask the the final velocity. Okay, so that's what are we going to do the next slide. Okay, any questions from here? So the only force you are getting from the electric field knowledge, E equals to F over Q and equals to V over D. You can find the force. Once you got a force, you can find the acceleration, F equals to ma, then SUVET after that. Okay. Okay, motion in a charge in a uniform electric field. So if you have a negative charge in the electric field, negative charge, of course, the force is going to be upwards. So it's going to experience a one-dimensional movement, just go straight up, Okay. So if a stationary electron is placed in the same electric field, the resultant electric force will be directed towards the plate A. So you're going to accelerate up with uniform acceleration. Acceleration is constant. Why acceleration is constant? The force is constant. Why force is constant? Because the field is constant. It's a uniform field. Okay. So if a question asks, moving straight up is a 1D, not much of a problem. Use a SUER, you can find the time taken to cross the plate. You can find what is the final velocity because it's 1D. But it's going to be more complicating if they show like this, the charge moving horizontally and the field line is like perpendicular to the direction of movement. Then here got lots of problem. What's the problem? You see the positive charge here. The positive charge is going in. Where's the direction of the force when it gets into the field? The force will be up or down. Here the field will be down, but it was projected horizontally with the U. So the acceleration is downwards. Okay. So if anything, the acceleration is perpendicular to the direction of movement. The particle is going to end up getting what path? It produces a parabolic path. Okay, parabolic path. This is two-dimensional 2D motion and 2D motion. You already learned 2D motion. What is that? Your projectile movement, right? Your projectile is 2D one. Now the problem is the projectile. They'll ask about all the questions about projectile now. Okay. For example, if the positive charge is launched with a particular velocity, maybe 200 meters per second, they will ask, they'll give you the V and D and everything to find the electric field strength. So the first question they will ask is, when the charge particle get in, what is the force the charge particle experience? So use your electric field knowledge. Force is what? QE. And we know E is V over D. We can find the force. Then after you find the force, we can find the acceleration of the charge particle. Once you know acceleration, they will ask, what is the time taken for this charge to cross the plate? When it crosses the plate and come to the end, what is the speed it's traveling? What velocity is traveling when it leaves the plate? And what angle it traveling from horizontal when it leaves the plate? This kind of question they're going to ask. These all are projectile. Okay. So when the charge particle move horizontally, how do you deal with projectile last time? You have to get vertical and the horizontal component. You need to get a vertical and horizontal component. Okay. So yeah, last time AY is negative 9.81, but in this case, the AY for electric field is different. This is the only different AY. How do you find the AY? By using the force. By using the force Q, you find the AY. Okay. AY first you need for AY is how do you find AY? Okay. Need to find the force first. How do you find the force? Force is QE. So after you find the force you change to MA. MA is QE. So now you can find the AY. AY is QE over M. Yeah, this is your AY. QE over M is your AY. Vertical acceleration. Vertical acceleration. So AY is not going to be 9.81 anymore because it's electric field. Electric field, the field gives its own AY. The AY is going to be very huge or very small. Normally going to be very big number. Because it's a charged particle which possesses a very little mass, the AY will be very huge. Okay, so AY not constant for electric field. Last time gravitational field AY is 9.81, but electric field AY going to vary because AY depend to the charge of the particle, the field strength, and the mass of the particle. Okay, AX will be what? Anyone? AX is going to be like last time. It's going to be 0. And the horizontal acceleration is 0. Horizontally never accelerate because the force is vertically down. Okay, therefore horizontal acceleration is 0. So yeah, So you need to get your AY, AX, you need to get your UI, UX as usual. And you have to work out the time to cross the plate and everything. Okay, this is just the introduction to tell you what's going to happen. So if it's 1D, no problem. We can use the SUET, easy. Okay, you get the 3 information, you can use one of the SUET equation, you can find the answer. Okay, but if it's launched horizontally, then you have to put vertical and horizontal. Try to collect the information now as usual, same as projectile, but only the AY is not 9.81 anymore. You need to calculate QE over M. It's electric field, it's not gravitational field. Okay, at this movement, when it going divert down, okay, we neglect the gravitational effect. Okay, in electric field, when the charge is moving down, we neglect the gravitational effect because the gravitational force is said to be far weaker than the electric force. Okay? Electric force is going to be very dominant. Okay, so we neglect gravitational force here in the calculation. Okay. Okay, so when a proton enters electric field perpendicularly, the downward electric force will cause the proton to move along a parabolic path towards plate B. This is similar to the motion of a ball projected horizontally above the ground. Okay, this is the tough part of this topic. Okay, any questions so far? Okay, so I believe you can understand more when we do one question about this. Okay, so same as the ball launching from the ground. Okay, if a negative charge is getting into horizontally, of course, it's going to move parabolic path again towards a positive charge. The electron is projected perpendicularly into the electric field. The electron will move along an upward parabolic path. Okay. So now, so key points to remember is the electric field lines are drawn from high potential to low potential, from positive to negative. The electrons carries the negative charge of negative 1.6 times 10 to the power negative 19 given in the formula list, in your constant list, front page. Electron is attracted to the positive side, so goes against the field. Okay, this you know that. The proton carries the same magnitude as the electron, but positively charged. 1.6 times 10 to the power negative 19. The proton is repelled by the positive side, so moved in the direction of the field. Okay. Okay, so now we go to exercise. As I told you, recall back projectile movement. Check is it 1D or 2D movement. Okay, the first exercise, warm up. Okay, you see in the diagram, there is a negative charge particle moving upward, positively plate. The electron is charged that its uniform electric field is 120,000 volt per meter was applied. Okay, first question, find the force on it. Okay, class, come on, take your pen, just work out. Now your turn. Try to have some working. Okay, take a piece of paper, just try to get the answer. What is the force on it? What formula do you use? Recall back. So what force do you use? Force formula. So F equals to QE. Is the formula must come to your mind. Okay, so QE we know this is the Q. It's a Q. And E we know is 120,000 volt. Make sure the units are SI. Q is coulomb. E is volt per meter is SI. So you get the force answer. Okay. So in this case, you should get 1.92 times 10 to the power negative 14 Newton. Okay. So as I already told you, they will ask force, they will ask acceleration, then it's going to be a SUET. Okay. That's the normal flow. Okay, next. We know the force exerting on the electron is too small or too big, the force. The force is very small. The force is very small on electron. Yeah, because the charge is very small. But the acceleration is going to be huge. What is its acceleration? if the mass of electron is 9.1 times 10 power negative 31. So what formula do you use? Anyone?
Equals MA.
Yeah, F equals to MA to be used. You already know force from the part A, so you know the mass here. So you find the acceleration. You find the acceleration, force over M. So give you acceleration. So acceleration is going to be huge. So in this case, if force divided by mass, you should get this answer. 2.11 times 10 power of 16. Acceleration is so huge, 10 power of 16. Okay, just like a split second, not even millisecond, smaller than millisecond. You're going to cross the plate, just disappear. Okay. Okay, now comes in. Work out for me. 1 minute for you. Okay, 1 minute for you. Work out. Give me the answer. The time it takes to travel 20 mm from rest. Anyone? So the time it takes to travel 20 mm from rest. That means it's going up for a distance of 20 mm. You move vertically up for 20 mm. 20 mm. They asking what is the time taken. So Suet, do you have three informations? What are the three informations you know? Anyone?
The total distance.
So you know the distance. You know the distance. Distance is how much? Is 20 mm. So 20 times 10 power of negative 3. Put it in meter. What else you know? Because you need to find time. Do you know U? Because initial velocity, do they see anything? Do they start with moving? It's from rest. So U is 0. What else you know? You know the D. D is S. D is, I put S. That is displacement. U. Then what else you know? Earlier you calculated A. What? So you know the A. A. You know the A. So you know S. You know A. You know U. You are looking for time. So what formula do you use? Without V.
S
So S equals to
UT plus
T
half
plus
A.
half AT squared. Yeah. So you substitute all the information, find the time. So it's a 2 Okay. So be sure the D is in a meter. Anyone? Answer? You should get 1.37 times 10 power of negative 19. So 1.37 times 10 power negative 19 seconds. You should get. The time is too small. The acceleration is so huge. Okay. So remember, don't think you are wrong if you get acceleration is very huge. It's going to be should be huge because the electron is a very lightweight. Okay, this is an easy question because it's a 1D movement. Just moving up straight. The tricky one is projectile. That's what we're going to do next. Okay, so recall back projectile. Okay, so this is still okay. Sorry, before that, this is another one example. Okay. So oil droplet was placed between the electric field. Okay. So yeah. So please do these two questions. I give you 1 minute. Just for you to do first. I just give you 1 minute. Think about this question. You give me a minute. sorry. Okay. So, anyone got the answer? So, a small oil droplet of mass 0.2 gram is placed between the two charged metal plate. It is held stationary due to the presence of a uniform electric field of strength of that. Draw a label diagram. The force acting on the oil. So, what are the forces acting on the oil? The force acting up is the, of course, going to be the electric force, the force due to electric. And what is the force acting down? It's going to be its weight, right? mg. Okay. Okay, class. Okay, you have to remember this carefully. As I said, if the charged particle going into the field crosses like projectile motion, the weight is neglected. Okay, the weight is neglected. Okay. For the case like this question, this is another type of question. When a small oil droplet was stationary, when they say a small oil droplet is stationary, then the weight is not neglected. The weight is considered. The weight is considered. Okay, because the field going to be quite small. Okay, so therefore it's comparable. The force of the electric force will be comparable to the weight, so we consider the weight. Remember, there are two types of electric field questions. One, the one moving, projectile movement, weight is not considered. The one stationary, weight is considered. Okay, weight is considered. The field is going to be very low, so the electric force is going to be comparable with the weight. Okay, so a small oil droplet of 0.2 grams placed between the charge plate. So first question, draw the force acting on that. We already done that. Find the charge on the stationary oil droplet. So anyone got the answer? How do you find the charge on the oil droplet? So how do you start your working first? What equals to what? What equals to what? Force of the electrical force must be equals to weight. Okay, the electric force must be equals to the weight. So electric force, what is the formula? Electric force is could be QE, right? QE. Yeah, QE equals to mg. Yes. Yeah. So from here we can find the charge. What is charge? Charge is mg over E. Yeah, correct. So you can find the charge. So mass is what? Mass of the oil droplet, 0.2 gram, changed to kilogram. And the gravity we know is 9.81. And E is 2.7 times 10 to the power of 5. You get the charge. Okay. So how much all of you got? I think you get 7.3 nanocoulomb, or in other words, 7.3 times 10 to the power negative 9. All of you got this answer. So the flow is quite simple. The electrical force equals to the weight. Weight not neglected for oil drop experiment. And we can find the charge of oil drop experiment. Okay. Okay, this is a very important experiment in science, the oil drop experiment. Okay. Why this is so important? Because this is the method used to find charge of electron. You know, charge of electron is how much? 1.6 times 10 to the power negative 19 coulomb. How scientists found this charge of electron? By oil drop experiment. By make an oil drop carry some charge to be stationary in electric field, they use QE equals to mg to find the charge possessed by the electron inside, because oil made of electron carries the charge, and they found the charge. Who found the charge of electron? Which scientist found the charge of electron? Millikan. Okay, Millikan found the charge of electron in 1923, if I'm not mistaken. So because he succeeded finding the charge of electron, he got a Nobel Prize in 1923. Okay, so Millikan found the charge of electron by using electric field, parallel plate, by making a oil droplet to become stationary. You can check this in your net a lot about Millikan and how he got the charge of electron. Okay, so when you consider charge of when oil droplet stationary in electric field, the weight is not neglected. Okay, any question from this slide? So not much of a tricky one. So charge of electron, just make force is the same. So you can find the charge of electron. Okay. Okay, now this is the worst one. As I take projectile movement. Okay, electron was fired horizontally in a parallel plate. The electron moved deviated up. The plate width is 4 centimeter. The charge of electron is 1.6 and the mass of electron is 9.1 times 10 to the power 31. It's given at the bottom. We're going to use these two. Okay, let's work out together. First, given that the electric field is this much, 2.3 times 10 to the power 4 Newton per coulomb within the plates, the horizontal velocity of the electron is 3.7 times 10 to the power 7. The electron was fired into the electric field horizontally, 3.7 times 10 to the power 7. Okay, recall back your projectile knowledge. First question. The acceleration of the electron, if gravitation force can be neglected. Okay, please give me the answer. 1 minute for you. Okay, this is important. You must give a try. This is the difficult one. Calculate the acceleration of the electron. What formula comes to your mind? Find the acceleration of the electron. So, of course, to find acceleration, force formula, right? So, acceleration, to find acceleration, I put AY, because we know it's going to be projectile, so it's vertical acceleration. It's going to be the, of course, the FOM, the vertical force over the mass of the electron. But the force, how much the force? Force, how do you find the force? QE. Q times E is the force, so M, yeah, correct. Okay, good. Yeah, so this is going to end up give you the acceleration. The charge of the particle, the electric field, divided by the mass of the particle will give the acceleration. So charge of the particle is how much? Because it's an electron, so charge of the particle is 1.6 times 10 to the power negative 19. Mass of the electron is 9.1 times negative 31. And the field is 2.3 times 10 to the power 4 will lead you the acceleration. It should be huge. So anyone got the answer? So I believe all of you got 4 times 10 to the power of 15.
Yes.
Got 4 times 10 to the power 15. Okay, so this is the technique. Okay, so A is FOM. You know this before. F is something new. QE, charge times electric field. You can get the force. Okay, got acceleration. And remember, this acceleration is your AY value, vertical acceleration. Okay, let's continue.
So,
Yeah.
do we need to consider the negative sign on the charge of electron?
No need.
Right.
No need. Okay. Okay, now let's continue. Okay, next. Okay, now I give you time again. Okay, 2 minutes for you. I give you 2 minutes. Okay, use your projectile knowledge. Use your Suvet formula. Get me the answer for this. The time that it takes to travel 4 centimeter in electric field horizontally. What is the time it takes to cross the plate 4 centimeter? 2 minutes for you. Use your projectile knowledge. Put vertical or horizontal. Gather your informations. You are looking for time. Do you still remember last time projectile movement? Time is the only quantity can be transferred from vertical to horizontal. So check which side you got 3 informations, you can find time. Okay, so my advice, put vertical, horizontal. Vertical, horizontal. You are looking for time. I don't know whether it's going to fall under vertical or horizontal. You don't know, check the information. Vertical, what are the informations you know? You know AY already, this is AY. AY is 4 times 10th power of 15. What else you know? AX is how much? Ax, as I said, is always 0. What else you know? Do you know uy? Do you know ux? Anyone? What is ui? It's a horizontal launch. It was launched horizontally. Do you still remember last time projectile movement? Like dropping a ball launched horizontally with 50 meter per second, let's say, it goes down 50 meter per second. What is your uy value will be for that ball?
0.
0, right? Horizontal launch. So same thing goes for because electron is launched horizontally. So here uy will be 0 because horizontal launch. Ux will be exactly same. It was launched, same speed as it launched. So ux is 3.7 times 10 to the power of 7. Okay, you want to find time. Not enough. You need 3 informations. So what else you know? Anyone? Another one information.
Sx.
Very good. Sx. Sx you know is 4 cm. Or you put in meter. So 4 times 10 power negative 2. Yes. So enough. You got 3 informations. Horizontally. Horizontally you have 3 information. So we can find time by using horizontal. Okay. So what formula comes to your mind? You're looking for time. So SUA is there. So the formula must come to your mind is what is that? S equals to UT plus half AT squared. Yes, this the formula must come to your mind. All x component we use. X component. Okay, so substitute your informations. Normally, if those who did a lot of projectile, half ax t squared going to be 0 because ax is 0. So it is going to be 0. So actually sx equals uxt. So the time is just sx over ux. You get the time. Okay. So hope you get 1.1 nanoseconds. Or in other words, 1.1 times 10 power of negative 9 seconds. Okay, I hope that's the answer you get. So Sx is 4 times 10 power of negative 2 meter and divided by what? The Ux is, Ux is what? Sorry, Ux is 3.7 times 10 power of negative 7 should give you, should give you 1.1 times 10 power negative 9 seconds. Or is nanoseconds. Okay, I think so far should be okay. Just important is those who got this information correctly. If you got this information correctly, you are on the correct track. Okay, so let's proceed more. Okay, so now they ask for the time. Okay, now we go to the next slide. The question continues. Okay, let's see. Now the question continues. Get me this answer. 2 minutes for you. The resultant velocity of the electron when it leaves the electric field. Okay. What is resultant electric field means? Resultant velocity means what? There's a parallel plate. Electron going in, it's deviating up or down? Or it's positive, it's going up. So they're asking what? Actually, let me come out this. We can stick with this slide. Are they asking what? They're asking what is the velocity it comes out? What velocity when it comes up from the plate? What velocity comes up from the plate? Okay. Okay. So how do you find this velocity? You need to find anyone can give you a clue? How do you find this final velocity when you leave the plate? How do you find V for projectile movement? Let's say a projectile is launched going up in somewhere at one particular time. They're asking what is the V? How do you find that V? You need to calculate the Vy and the Vx, right? Recall back. You need to get the Vy and Vx at that time. Then after that, how do you find a V? Projectile, your Pythagoras, right? Vx and Vy. So you can work out your V, right? Yeah, it's the same concept. How do you find the V here? So when you leave the plate, you need to find how much the Vx it has, how much is the Vy it possesses. If you know the Vy and Vx, you can find the V. Okay, Vx, do you know the value? So go back to this projectile knowledge, this data. Do you know Vx? Vx is same as what? Always same as Ux, right? So Vx, we know, is same as Ux. How much? 3.7 times 10 power 7. So Vx is no problem. It's 3.7 times 10 power 7 meter per second. Okay. The problem is the Vy. Do you know the Vy? How do you find Vy? So go back to the data. You need to know the Vy. How do you find Vy? You have three informations vertically. You know Uy, you know Ay. Do you have another one information needed? What information? The third one you know? You know the time now. You know the time now. What is the time taken? 1.1 times 10 power negative 9. So time you know. Time is 1.1 times 10 power negative 9. So find the Vy. So what formula do you use? Time, you know, A, you know, U, you know, you're looking for V. Use without S. So V equals to U plus AT. Can give you the Vy. Okay. So how do you find the Vy? Vy you can find by using Vy equals to U plus U plus AT. AYT, yes, correct. So can give you the Vy. So once you know the Vy and Vx, of course, I believe you know how to find a V. How to find a V? V squared equals to Vy squared plus Vx squared. So you can find a V. Okay, class, just spend some time, 2 minutes, get me the answer for the V. I remain in this slide before I go to the next slide, because all the information is here. Okay, tell me if you have an answer. Anyone? So anyone got the answer? So you want to find the V. So you need to look for Vx and Vy. Vx is same as Ux. Vy is the problem. Vy use the vertical component. Uy 0, Ay, you know, T. Just now you got, use the T to find the Vy. Once you got Vy and Vx, we use Pythagoras to find the V. Same as projectile. The only difference is what? The only difference is the Ay is different. That's it. Last time Ay is we fixed negative 9.81. But here the Ay going to change because it depends on the field, electric field. Okay. Okay, so anyone got the answer? The resultant velocity?
.73 times 10 to the power 7.
Okay, so all of you get that, 3.73 times 10 to the power 7 meter per second should be your answer. Okay, I think the technique shouldn't be a problem, projectile. Okay, so let's continue. More questions comes in. D. Okay. So 1 minute for you. Get me the answer. What is the angle it makes? The angle it makes with the undeviated path. So of course, you know, the electron goes up, and when it goes here, going out, what is the angle it makes? What is the angle it makes? How much is the angle it makes from the undeviated path? Undeviated path is the straight line. So what does this angle stands for? Okay. So same like projectile, right? How do you find the angle? Tangent theta equals to what? Vy over Vx, right? Because we use the triangle of Vy, Vx, and V. This is the angle of deflection. So tangent theta equals to Vy over Vx. So you put the Vy and Vx, you can work out the theta. Shift tangent, get the angle. So Vy, just now we got, okay, put the Vy and Vx, then you get the angle. So important is, before I tell you this, those who figure out this is the idea to do, that's good. You understand? So the theta should get around 6.7 degrees, 7 degrees, 6.7 degrees. So that's the deviation of the electron when passed through the electric field. Okay, any questions so far? Okay, hope you can cope up. Okay, so let's be one E. Okay, no need to calculate, just work, think mentally, just visualize it. What will happen to the answer from A to D? The answer from A to D is that the value is going to become greater or smaller compared to for electron if proton is used. Repeat A and D if a proton is used. Compare the angle of deviation. First, let's go for the A. You go back A. Okay, let me clear these two. Okay, the A. What happens to the A answer if it's a proton? Electron has an acceleration of 4 times 10 to the power 15. Proton will have acceleration smaller than 4 times 10 to the power 15 or bigger than 4 times 10 to the power 15. With a reason. Anyone? Anyone?
Be smaller.
Will be smaller. Good. Why?
Has a larger mass.
Very good. Larger mass. Greater mass. Is it the force the same as electron?
Also,
Force is same. Why force same? Same charge. Same charge, same electric field. So force is same because the mass is larger for proton. So the acceleration going to be very small. So the A for proton going to be smaller. Reason is the mass of proton is very large. Okay, so acceleration is smaller. Okay, good. B. What do you think the answer going to be? Smaller than 1.1, greater than 1.1, or same as 1.1? The proton is launched with the same speed, 3.7 times 10 to the power 7. Okay, mentally you try to analyze. The time taken to cross the plate for electron is 1.1 nanosecond. For proton going to be more than 1.1 nanosecond or smaller than 1.1 nanosecond or same as 1.1 nanosecond with a reason. Anyone?
Same.
Same, good. Should be same as 1.1 second. Why? Because how define the time? Time is Sx over, sorry, what is that? Sx over the Vx, right? Sx over Vx. The Sx for both is same for cm, and the Vx, the horizontal speed, also same for both of them. So the time of crossing is the same. So no change. Good. So A decreases, acceleration decreases, time of crossing is the same. The third answer going to be what? Smaller than this or bigger than this? And reason, give me the reason why. Smaller or bigger? This is challenging. You have to think. Okay, hope you get the. So the V going to be smaller or bigger? How do you get your V? Vy and Vx, right? Vx for both of them same. What happened to the Vy for the proton when he crossed the plate? Smaller than acceleration Vy, for electron Vy, or the greater than electron Vy, the Vy value? Vy of proton going to be smaller or bigger? Smaller, right? Vy going to be smaller. Why? Anyone? Why? Why going to be smaller?
Larger mass.
Acceleration.
Very good. Larger mass. Larger mass. Therefore, the AY will be smaller. AY will be smaller. Okay. So when Vy gets smaller, what happened to the V value? Because Vy squared, Vx squared is your V. So when Vx is the same, but Vy gets smaller, so V value also going to be smaller. So the proton will have a smaller V. When it exceeds the parallel plate, the velocity going to experience is smaller than electron because the Vy is affected. Vy becomes smaller. Why Vy is smaller? Because mass is larger, therefore acceleration is smaller. Good. Vy is smaller. Okay, the fourth, what happened to the angle? So when Vy is smaller, what happens to the angle of deflection? The angle of deflection also going to be smaller, right? Because tangent theta equals to Vy over Vx. But because Vy gets smaller, so theta also will get smaller. So less deflected. So proton will be less deflected. So that's the answer. So repeat. So the angle, if you calculate the values, you will get angle of deflection at 0.004. It's going to be very small compared to the angle of deflection. Okay, but I don't want you to calculate. Okay, class. So this is today's lesson. Okay, I don't want to drag a lot. Okay, so the main part which you need to digest today is the projectile movement, the two-dimensional movement. That's the harder one. Other than that is something okay. Okay, so what you learned today? Okay, so what you learned today? So you learned about electric field. So you learned about electric field. Sorry. So the last recap. So what you learned today? Electric field strength is force per unit, positive charge, and VOD. By definition, use force per unit, positive charge. Unit is what? Newton per coulomb, volt per meter. Okay, so that is electric field strength. Okay, then we talk about the movement of the plate and the charge moving up or the charge moving horizontal. Okay, what do you call the weight of the charged particle is neglected. We neglect the weight of the charged particle when it's moving. Another time, if the oil is stationary, the mg same as the electric force. In this case, weight is not neglected. Remember, these are the things we learn today. Okay, if it's a projectile movement, recall back your vertical and horizontal knowledge. Ax, as usual, normally going to be 0. Your Ay is the something problem one. You have to calculate. Ay is what? F over m. Then F you get to find QE over m. Or to be expand further, the electric field could be in the V over D form. V over D over m. This is where you need to find the Ay. Other than that, everything is exactly the same as projectile. Okay, any questions so far today's lesson? This is a summary. No questions. Okay, class. If you don't have questions, so I don't want to drag further.
Sir,
okay. Yeah.
our test is consists of MCQ only, or is it structure and MCQ?
Okay, about your sem exam, you have 30 objective, 5 structure. 30 objective, 30 marks, 5 structure, also another 30 marks. So 60 marks paper. 60 marks paper, duration is 1.5 hours. Okay, 30 objective, 5 structure. 5 structure consists of 30 marks. Okay, until electric field. The problem you might face is time factor. Okay, because you just started your course in April, so very short period of time. So try to do your semester papers in your times. You got a lot of semester papers, right? Okay, towards the end we have that model, 30 questions and the 5 structures. So 60 marks, 1.5 hours paper. So give a try. The time factor, I think, going to be an issue for you. Any questions? Clear? Okay, so it's up to electric field. Okay, hope after we've done electric field, we have 1 or 2 classes, we can do some set papers. Okay, so if you don't have questions, we can stop here. Continue tomorrow. Tomorrow we'll be finishing this topic. Okay, so stop here. Thanks.